Okay, guys, this is section 1.3. Section 1.3 is about complex numbers and quadratic equation complex number system. So what I'm going to do, I'm going to start with the review. You guys know that something like this, x squared equal -1, has no solution in a real number system. Okay, so we cannot solve it because, again, any number square it has to be always positive. Okay, even if you will try to solve it using square root method by taking square root of both sides, you will end up with x equals square root of -1. Okay, so there is no real solution. Number under square root has to be positive. However, we can solve it this equation in complex number system. Complex number system by introducing imaginary unit which we call I, such that I is equal square root of -1 and I to a second power is just equal -1. So complex number system, it's the system which has imaginary numbers, the one which has I. So they are not real numbers. You cannot graph it in real number system. However, we introduce the complex number system so we can solve the equation like x squared equal -1. We cannot just say that something like this cannot be solved. Okay, so let me give you the definition because I just introduced imaginary unit, but let me give you the definition of complex numbers. Okay, so complex numbers are numbers which have form a plus bi, where a, we call it real part. It's called real part. And coefficient b, it's called imaginary part. Okay, so coefficient b, again, it's right here. We call it imaginary part. Okay, so let me give you the example of number in complex number system. You have -5 minus 3i. So real part will be -5. Imaginary part will be -3. Imaginary part. So complex number system, it's bigger than real numbers because has that real part, but also it has that imaginary part, which is the coefficient which you guys see in front of I, because it's a multiplication between them. Okay, adding complex numbers. Since we're talking about complex numbers, we need to review how to add complex numbers. Okay, so add a complex number. Note from me will be just combine like terms. Add real parts together. And imaginary parts together. Okay, so you have a plus bi. So this is the first complex number plus c plus di. So what you're going to do, you're going to add real parts together, which is a plus c, and then you're going to add imagine, imaginary parts together, which is bi plus di. So put b plus d because you can factor that I outside. So let me give you an example. 2 plus 3i plus 4 minus 5i. So first what I'm going to do, I'm going to add the real part. So I have 2 plus 4 plus, and I'm going to add imaginary parts, which is 3i minus 5i. Okay, so we will end up with 6 plus 3i plus negative 5i, which will give you negative 2i. So that's the answer. Difference of complex numbers, so you're doing the same thing. So let me just give you the example. Of complex numbers. Example, because your difference means add opposite. So we have, and if you follow the formula, a plus b I minus c plus di. So what you're going to do, you're going to subtract the real parts and you're going to subtract the imaginary parts. Okay, so example, we have 2 plus 3i minus 4 minus 5i. What I recommended to distribute that minus because that's where students messed up. So copy 2 plus 3i, negative 1 times 4 will give you negative 4, negative 1, because of course when you see negative, we know it's negative 1. Negative 1 times negative 5i will give you positive 5i. And now I'm going to combine like terms. So 2 and negative 4 will give you negative 2. And then you have 3i plus 5i that will give you 8i. And that's our solution. So always when you're writing the solution of complex numbers, real parts goes first and the imaginary parts goes next. Okay, let's focus on multiplying complex numbers. Complex numbers. So when we multiply complex numbers, you're just going to FOIL. Remember that I square is equal negative 1. So let me give you the example. 2 minus 4i times 2 plus I. So we're going to FOIL. So first, you multiply the first one. So we're having 2 times 2, that will give you 4. O stands for outside, so we multiply outside, which will be 2 times I, which will be 2I. So plus 2I. I stands for inner, so inner will be negative 4i and 2. So we're going to multiply negative 4i by 2. So we end up with negative 8i. And L stands for last. So last is negative 4i. And last it's I. So we end up with negative 4i times I, which will give you negative 4i squared. And we remember that I squared, when you see I to a second power, you always need to replace with negative 1. So I squared is equal negative 1. So this is just negative 1. So we have negative 4 times negative 1, which will give you just positive 4. So from L, I'm getting positive 4. And now I'm just going to simplify, combine like terms. So 4 plus 4 will give me 8. And 2i minus 8i, that will give you negative 6i. Okay, and that's our final solution. So you're just going to FOIL. Okay. I think this is fine how to FOIL. You guys can practice a little more on homework. Next, what I want to talk about I want to talk about complex conjugate. Or maybe let's just do one more. So I will call that A. Let's do B. Let's do one more with multiplication. Negative 6 plus I times negative 6 minus I. So I'm going to FOIL. So first, so I have negative 6 times negative 6. That will give you positive 36. Outside, O stands for outside, so you have negative 6 times negative I, that will give you 6i. I stands for inside, so I multiply I by negative 6, so that will give me negative 6i. And last stands for last, so you multiply I by negative I, and that will give you negative I squared. Simplify, so look what happened here. 6i negative 6i will give you 0. So we end up with 36, and I squared is just negative 1. So we have negative of negative 1. And that will give you 36 plus 1, which is 37. Okay, so not all the time when you multiply actually to complex numbers, you may end up with a real number. Okay, and that's happened when you multiply two conjugates. So let me give you the definition. Complex conjugate. Complex conjugate. If z, usually letter z represents the complex numbers, it's equal a plus bi, real plus imaginary part is a complex number. Then its conjugate denote by, and conjugate, you see that hat or dash on top of it. Z hat, Z dash, I'm sorry, is defined as conjugate A, and you also have BI, but look what happened, that plus, it's going to change to negative. So A minus BI. Okay, so conjugate, that means the operation in the middle switch to opposite. So let me give you an example. Find the conjugate of z equal 2 minus 3i. So the conjugate z dash, you're just switching the operation in the middle to opposite. So that will be 2 plus 3i. Everything else stays the same. So change the sign in the middle to opposite. To the opposite. That's it. That's how you find the conjugate. So that's the only thing. We're not changing anything else. Okay. So that was one practice. Let's do B. And in homework, they may give you something like this: -2 minus 6i, which you guys see, this is complex number, and you will have that dash on top of it. So what that means that you need to find the conjugate of -2 minus 6i, which will be -2 plus 6i. So I want to mention that sometimes they're not going to say find the conjugate, but if you see that dash, that means switch the operation in the middle to opposite. Okay, that's what that means. Very important rule: when you multiply two complex conjugate, you will always end up with a real number. Okay, so let me write this down. This is important. Multiplying a complex number by its conjugate maybe I'll put it like, when you multiplying complex number by its conjugate, the solution is always real number. So I will cancel. Okay, so let me, you can use the formula that complex times conjugate is just a squared plus b squared. Okay, go ahead and use that formula all the time when you multiply complex by its conjugate, where z is equal a plus bi and conjugate is a minus bi. Okay, and I quickly want to prove it, why you can use that formula. So let me just show you that complex times conjugate, a plus bi times a minus bi. This is proof. I'm just quickly going to prove it. So technically, without using the formula, you will need to FOIL. So I multiply a by a, that will give you a squared. Then a times negative bi will give you negative abi. Then I will multiply bi times a, which is the same as abi. And bi times negative bi, that will give you negative b square I square. And with I square, they are opposite, so that will cancel. And you have negative b squared. And I'm going to replace I square with negative 1. So times negative 1. And that's from where we have the formula a square plus b square. Okay, so that was the proof. You don't need to do the proof. You go ahead and use the formula. Only when you multiply complex times its conjugate. So I will give you a quick example using the numbers. So we need to multiply 2 plus 3i by its conjugate, which is minus 3i. So I'm going to use the formula, which is a squared plus b squared, because I have complex times conjugate. So you only use that formula when you have complex times conjugate. A, it's 2. So that's a. So that will be 2 squared plus b, it's 3. That's that imaginary part, plus 3 squared. So we're having 4 plus 9, and that will give you 13. Okay, you can use the formula a squared plus b squared all the time when you multiply complex by its conjugate only. Okay, when you have different type of multiplication, of course you need to FOIL. Okay. Next, what we're going to do, writing the quotient of two complex in standard form. So I don't think I never mentioned that the standard form of a complex number is a plus bi, real part then imaginary part. So next what we're going to do, we're going to focus on, this is important, writing the quotient of two complex numbers in standard form. Okay, so this is what we're going to do. You have in quotient, which is a fraction, 6 minus I over 1 plus I. How are you going to rewrite this quotient in a standard form, which is a plus bi, not having fractions? Okay, so hint for this is multiply top and bottom, which is numerator and denominator, by the conjugate of the denominator. Okay, so conjugate of 1 plus I is 1 minus I. So what we're going to do, we're going to take our original quotient, which is 6 minus I plus 1 plus I, and we multiply top and bottom by the conjugate of the denominator, which is 1 minus I, 1 minus I. Okay, so this is what we do. We multiply top and bottom by the conjugate of the denominator. Why we do that? Because look what happened. Here, when you multiply fraction by fraction, you multiply numerators together and denominators together. Since we already know that complex by conjugate, you can use that formula that will give you here a squared plus b squared. So that will give me 1 squared plus b. B, it's a number in front of I. So if you don't see it, that will be 1. So I have 1 squared plus 1 squared. Your numerator, no shortcut. Numerator, you have to FOIL. Okay, so I'm going to multiply each by each. 6 times 1, that will give me 6. Then 6 times negative I, that will give me negative 6I. Then negative I times 1, which is negative I. And negative I times negative I will give me I squared. Okay, so let's simplify that, especially numerator. So we have 6, negative 6I minus I will give you negative 7I. And you're going to replace I squared with negative 1. So minus 1 over 1 squared plus 1 squared, that will just give you 2. So we have 6 minus 1, which is 5 minus 7I over 2. Don't stop here. This is not the standard form yet. So to get the standard form, just split that into two fractions. So that will, this is the same as 5 over 2 minus 7 over 2I. This is your final solution. This is the standard form. How are you going to know that this is the final solution? Because standard form, you should know exactly what is your A, which is what is the real part, and what is B, which is imaginary part. Okay, so this is B. So don't stop here. Okay, that's not the end. Just split this over two fractions. Okay. I guess we'll practice one more. So we have 2 minus 3i over 4 minus 3i. So what you need to do, step number 1, multiply top and bottom by the conjugate of the denominator. So conjugate of the denominator will be 4 plus 3i. And I just recommended that you guys put in parentheses. Okay. Now, on the top, you need to FOIL. Okay. So we're going to FOIL. So we have 2 times 4, which is 8. 2 times 3i, that will give you 6i. Then negative 3i times 4 will give you negative 12i. Negative 3i times 3i will give you negative 9i squared. And on the bottom, you have complex times conjugate. So you know already this is a squared plus b squared, which will give us 4 squared plus 3 squared, which is 16 plus 9. And that will be 25. Okay. Okay. So let's simplify numerator. So that will give you 8 plus 6i minus 12i. That will give you negative 6i. And I square you're going to replace with negative 1. So negative 1 times negative 9, that will give you 9. And everything over 25. And now we're getting here 8 plus 9, which is 17 minus 6i over 25, and just split this over two fractions. And this is the final solution. This is the standard form. So all the time when you see a quotient with complex numbers, you need to multiply top and bottom by conjugate to change it to a standard form. Okay. Okay, there's a couple things which I have to teach you. This is the long section. So I will break this video into 2 videos. Let's do more examples. Writing other expressions. Writing other expressions. In standard form. Okay, so here we have if z it's equal 2 plus 3i and w equal 4 minus 5i, write each of the following. Write each of the following in standard form. Okay, so A. I want you to divide z divided by w. So z it's 2 plus 3i w, it's 4 minus 5i. So don't forget that you need to write your solution in standard form. So to do that, we need to multiply top and bottom by conjugate of the denominator, which will be 5i. Okay, so we multiply. Numerators, remember, you have to FOIL. So we have 2 times 4, we have 8 plus 2 times 5i, which is give you 10i, then 3i times 4, which is 12i, and 3i times 5i, that will give you 15i squared over, and don't forget to use the formula that when you have complex times conjugate, you can always use a squared plus b squared. So a it's 4 to the second power plus b. Again, it doesn't matter if you put negative or positive, because even if you put negative and you square it, you always end up with positive. So that will give you just 16 plus 25, which we're getting 41, right? We're getting 41. So on the bottom, we're going to have 41. Let's simplify the numerator. So we have 8, 10i plus 12i will give you 21i. And this I square we're going to replace with -1. So 15 times -1, it's -15 over 41. And this is just 8 minus 15, which is -7 plus 21i over 41. And now what you're going to do, split into two fractions. So -7 over 41 plus 21 over 41i. 21 or 22? 22. I'm sorry. That should be 22. 22. 22. And here it should be 22. So we have 22 over 41i. And I'll just do one more. Going back to this problem. So b, we're going to use the same information that z is equal 2 plus 3i, and w is equal 4 minus 5i. And in b, what I want you to do, I want you to add two complex numbers and then the conjugate. So what we're going to do first, note, add complex numbers first, then take the conjugate of the sum. Sum, again, is the answer of adding two expressions. Okay, so we have z plus w, and then we have to take the conjugates. So first, what I'm going to do, we're going to add two complex numbers together. So z is 2 plus 3i, w is 4 minus 5i, and then we'll have to take the conjugate. Again, don't forget from where I'm taking that. Here. Z is equal to 2 plus 3i, w is equal 4 minus 5i. Okay. So, conjugate. Now I'm adding two complex numbers together, so you're adding the real parts first. So 2 plus 4, that will give us 6. And then I'm adding the imaginary part, so we have 3i minus 5i, that will give us -2i. And now just take the conjugate of 6 minus 2i, which will be 6 plus 2i. So this is the final solution. Okay, so let me start giving you a couple definitions about complex numbers and its conjugate. So this is the definition. Conjugate of a real number is the real number itself So let me give you an example. Let's say z is equal to, so you don't have that imaginary part, but you can always add it, that's 0i, which is just 0. So the conjugate of z will be 2 minus 0i, which is just 1. Okay. There are a couple theorems which you guys need to know. So let me give you the theorem. Okay, there's a lot about, but there's an entire section about complex numbers. Okay, so just stay with me. Theorems. The conjugate of the conjugate is the complex number itself. Which means conjugate of the conjugate will give you original complex number. Okay, so let me just give you the example. Z is equal to 2 plus 3. So if you need to take the conjugate of the conjugate, so 2 plus 3i conjugate of conjugate, I'm going to leave that proof for you guys, but that's just going to be the original complex number. I'll stop here, and I will record a second video for you guys soon. So I will stop here.